Hi everyone, welcome to Same Sunday Artifact Adventure Video 4. I'm Alice Merkel, I'm a collections assistant here at the Maryland Archaeological Conservation Lab at JFPAT. And in this video, the last video we already talked about labeling, sorting, and mending artifacts that mend back together. But what do we do? How do we figure out what exactly those artifacts were part of if we can't mend something? What do we X-ray? What do we conserve? What does conservation mean? And how do we figure out what those artifacts may have been a part of? Well, in today's video, we're going to talk about both conservation with our conservators, Heather and Francis, and also Tricia, about how we compare these artifacts that we find in the field to our type collection here in the range to figure out what we found.
Hi, I'm Heather Rivardi. I'm one of the conservators at the MAC Lab, and today I'm going to tell you a little bit about what conservation is and why it's important. Conservation is caring for artifacts of cultural importance, social importance, or even historical importance. So conservation includes everything from making sure that an artifact is handled and stored correctly according to its individual needs or the needs of the material, to chemical interventive treatments to stabilize something that's really in need of care and attention. So right now I'm working on 2 external projects and a handful of projects for the curator of the state collections. And the external projects are really cool because they include a Revolutionary War era musket, which came to us late last year. And I'm basically reconstructing 2 halves of the musket that came apart. And I'm also working on a World War I era bed frame, bed head. Now what's cool about the hospital bed frame from the World War I era is that it includes very clearly the insignia for the U.S. Army Quartermaster Corps branch.
Hello, my name is Francis Lukacic, and I'm a conservator here at the Maryland Archaeological Conservation Laboratory. And today I want to tell you about one of our most used and favorite tools here at the lab, and that is X-radiography. So here at the MAC Lab, we use X-rays to look at artifacts in a number of ways. So firstly, it really helps with identification, particularly for, a lot of iron artifacts come to us completely encased in soil and corrosion, so you really can't see what's inside. So the X-ray is terrific at showing you what is in that accretion. Another way that X-rays are useful too is to show the condition of the artifact. Perhaps you can tell, like, oh, I know what that artifact is, but an X-ray can show you the inside of the artifact and the level of preservation, such like how much metal is actually there for, like iron artifacts. X-rays are also useful for looking at the way that the artifacts are constructed or how they're manufactured. Some artifacts consist of multiple pieces or components, and that X-ray can be incredibly useful to see how those components or pieces fit together. And in some cases, there are marks, manufacturing marks, that may not be visible at the beginning of the treatment. And again, the X-rays are useful in highlighting something we may miss. So X-ray is also very useful to us, particularly when we're looking at firearms and ordnance that we work on here at the lab. Because we want to make sure that they're not still loaded and not a danger to us or the facility. And of course, we take safety very seriously when we're using our X-radiography unit. So I'm wearing a dosimeter badge which monitors my potential exposure to X-rays. And we also have a survey meter that we use while the X-ray unit is running. So again, we can also monitor any potential exposure to X-rays. So when we are setting up an X-ray on the digital plate, we take into account like what artifact material is in order to make sure that we're using the appropriate settings on our X-radiography unit. So we will also add this information to the digital plate. So we'll indicate the kV or the kilovoltage, and that represents the energy or quality of the X-rays. The other setting that we add is MA, or the milliamperes, and this represents the intensity or quantity of the X-ray. Scale, so that we know what size, you can see what size the artifacts are. And then we'll also add like how many seconds or the time that we're exposing the plate. We're now ready to take the plate with the artifacts on top of it into the X-ray room that is fully lead lined, so again another protective measure. We'll then place it right beneath the unit on a table, and we just ensure that we place it within the cone of energy. So after that, once everyone is safely out of the room, we'll then close the doors. Once we press the start button, we'll get a warning signal to let us know that, okay, the unit is about to X-ray, and then it will start. And then it will go for how long or how many seconds or minutes that we set the unit to. So in this case, it was just 30 seconds. And during that time, I'm using the survey meter and passing it along the joints of the doors to make sure there's no possible X-rays escaping the doors. Okay, so the settings that we use, like I mentioned before, are adjusted based on the material that we are X-raying. So with metals, that kilovoltage I mentioned earlier is going to be a lot higher than, say, for the X-rays that are used or the kilovoltage that's used to take X-rays of like our teeth or our bones. In this case, the X-ray that we did today, the kilovoltage was 200. Well, that's definitely amount of X-rays for the human body.